If you don't know this, then you are actually limiting yourself to this number and you are going to run into many problems. If you're talking about providing prompt to the LLM via the Ollama, maybe your prompt is too long. You are facing with long input text. On the other hand, if you don't set the num predict properly, then your summary get cut off. This is something that you might have missed. It's hidden in a warning that your input prompt is being truncated. Don't forget to give us likes, leave your comments, share us to your friends, and also subscribe to our channels. We have YouTube, LinkedIn, TikTok, and Facebook. Alright, the second half is going to be technical. We are going to start with context length in Ollama. So what is context length? Context length have many forms, right? The first one is the LLM's context length itself. This is the context length that the model is trained on. Beyond that, it's going to get worse. For example, like Llama 3.2 has a context length of around 128,000 tokens. GPT-4o is roughly the same thing. Gemini 2 Flash or 1.5 Pro, the context length is 1 million tokens. But what I want you to think of it is, this is the maximum number of tokens the model can make sense of. Text or token series longer than this, it's going to lose its mind. It's going to make mistakes because it just overflow out of this. All right. Now, when we are implementing LLM with Ollama, Ollama has a context length or context window as well. And this is controlled by an argument called num_ctx or context. And the default value is 2048. If you don't know this, then you are actually limiting yourself to this number and you are going to run into many problems. That I will show one problem right in this section. So if you want Ollama to summarize a text and you have this small context window, what can happen is that the context input text can be larger. But anyway, whatever you do in Ollama has to be within this Ollama setting context window. If your input text is really long, then your summary would get like squashed out too. So basically, these are all the lengths of the tokens, token lengths that you need to think about. The first one, to recap, is the ultimate token length, limited by the model's intrinsic ability to know itself. Now you are implementing Ollama. You have a knob to tune it, to set a context window to your liking, to suit your application, and you need to do that. All right. You need to be taking care of how long is your tokens and how long you want the summary or the response from the Ollama to be generated. And this number is actually controlled by num_pred, the number of predictions, and the default is 128 tokens only, or maybe 256, maybe wrong here. But again, this value is fixed, and if you don't know, then you are capped. You are limiting yourself to many possibilities. Okay, so the challenges, as I mentioned, is if you're talking about providing prompt to the LLM via the Ollama layer, maybe your prompt is too long. You are facing with long input text. In our today's sessions, we are going to talk about summarizing a text. And one of the application here is summarizing a very long text. Let's say the text is 4,000 tokens long. And if your Ollama setting is only set to 2,000, then how are we going to handle that, right? We are running into a long input text problem. On the other hand, if you don't set the num predict properly, then your summary get cut off. If you want the model, let's say, to summarize input text in detail, and detail can means like 300 tokens in the summary, but you cap yourself, you don't know that, you cap yourself to 128, then your summary is going to get chopped, right? Summary cutoff is a problem when you don't set the num predict properly. So let me actually show you with this problem in coding demo. So this is available on my GitHub repo, Llama nuggets. I plan to add more nuggets in this repo, but the first nugget is about the context length. So let me bring up the Visual Studio Code for this. All right. So yeah, I started using GitHub Copilot because it's free and it's quite useful so far. Anyway, so let me bring your attention to this. So let me clear everything. All right, so this notebook, it's only one in this subfolder called context length. This notebook is going to go through steps to show you the problem that we will face if we don't set the context lengths, the num underscore ctx or num pred properly. So we are going to load up LangChain stuff like Ollama, tokenizer, and everything else. This is not used, but anyway, I prepared a sample text in the file here, and it's actually consists of about 200,000 character in it. So for the first 500 characters is like this. This is a transcript from a YouTube video featuring Andre Kapati 3 years ago. It's an interview with a moderator, not a moderator, a host and Andre. It happened for 3 hours. The guys were talking for 3 hours nonstop, and this resulted in this long. And if I want to summarize this, I am going to run into the long input text problem. But anyway, so let's focus on what we have now. I have two helper functions. The first one is to split the long text into chunks. We are going to cover this in the next topic, but for now, I have text split into smaller chunks, and I have a function that can count how many tokens in a given text. And this is what we are going to use most of the time here. So I am going to just pick the first 50,000 character or letters from the actual transcript, and I'm going to divide the chunk. Actually, let me just introduce chunks. All right. If the input text is too long, one of the ways to handle that is to chop it into chunks. And the way to do that is, let's say we want to have a chunk of 10,000 tokens, or the chunk should have around like 10,000 tokens. We'll do that. We'll have a method to chop the chunk, chop the text into chunk, and the function that we are going to do is this guy. This guy would take chunk size, how many tokens in a chunk should have, and overlap size. It means how many tokens that the first chunk and the follower chunk should have. So this is the overlap size. And I'm using the recursive character text splitter from LangChain library to help me do that. So let me set the chunk size to 2,500 tokens. This is in tokens, no overlap. So what this is going to do here is to prepare a document. This is just a procedure. You have a text, you prepare document objects, and you create your text splitter, and then you use your text splitter to split the document into split docs. And when I run this, you are going to see that I have 4 split documents or 4 chunks. Why? Well, roughly we have this is characters, by the way. This is not token. This is letters, not tokens. It's quite misleading, right? Because 50,000 divided by 2,500 is not 4. It's misleading, but you can come and see here. There are 4 split chunks, right? The character in each chunks are like this. Roughly the same, but 12,000-ish, but not 200 and 2500. That's characters or letters, right? But if you count tokens, it's roughly 2500 as I specified. In total, the whole thing, the whole chunk, the whole text here has got about 9,000 tokens. Anyway, I have a large text. I split it into chunks. Each chunk is about 2,500 in tokens. Now, I am going to define my model. I'm going to use Llama 3.2. I'm using Ollama here, a temperature 0.5, and the number of the context length of Ollama, right? Remember this length. This is the length. This length is right now is around 1,000. But if you recall, the chunk itself, forgetting about this, the whole chunk itself is 2,000. So it's overflowing, right? It's long, larger. I will execute this. Now I have my model ready. This is the template. This template will say, write a detailed summary of the text section in the bullet point, and I provide the text in chunk here. So this is a kind of like a prompt template, and then I will fill in the information in the placeholder like this with the first document, the first chunk in this manner, and I will print out to you what it is. All right, I run this. I am printing full prompt, but before that, you can see that now the full prompt has around 2,500 tokens. And this is actually the whole prompt. Write a detailed summary of this text section in bullet point, blah, know the text. And this is the actual chunk from the original text stuffed into a prompt template. And the prompt template ends with summary according to what I have here. So pretty much this is a prompt template that I will now put into AI or the LLM, and it will ask it to summarize for me, right? This is case number 1. I'm showing you overflowing. This is a case where the Ollama context length, this guy, is only 1,000, but the whole input text, the full prompt in this case, is 2,500. All right. What I want to show you here is also, you can see the symptom from Ollama. So, okay, now I'm serving Ollama for running. So if I execute this, it's going to send a full prompt, this one, to the LLM. The LLM would then generate response from me, now called output. So let me just do that. All right, here, this is what I want you to focus on. So it's kind of like be pushed down a little bit. Now I need to find it. Where is it? Here. Here we go. This is something that you might have missed here. So again, in this case, the Ollama context length is only 1,024, but our prompt is roughly 2,000. So it's hidden in the warning that your input prompt is being truncated, right? So this is going to be a problem. You are not going to get full performance because your prompt is being truncated. So basically, it might be only seeing the first part of the prompt, the first 1,024 tokens, and this is what it has generated. That's a problem. Then another symptom that you see here is it doesn't look like it has finished its sentence too. But that's the prompt for later. All right. Now we are going to move to a case where everything, the prompt here or the input text is within Ollama context length. So before I do that, let me just clear everything here and Ollama serve again. I am going to triple the context length of Ollama from 1,000-ish to 3,000-ish, and everything else remain the same. So I am going to run this code now. Okay. All right. And oh, I also run that as well. So if you go up a little bit, you're not going to see warnings of being truncated. You don't have it there. So this is fine. It means that you increase or enlarge your context length of Ollama to support the input text that you need to process. But again, for this case, you still see that this doesn't seem like it's a complete sentence. If it's a complete sentence, it should have a full stop. So we need to solve that problem too. I'm not going to run this code. There's no point now. All right, so let me just, what I'm going to do here is I keep everything else the same as above, meaning context length is around 3000, but I am going to increase the number of prediction. Something to notice is that the context length is 3000, right? The number of prediction is 1000. So in total, if we come back to this page, this length, input length, is around 2.5 thousand, and this is 1000. So this maximum is 1000. So now is like 3.5 thousand tokens, right? So that's risky. That is this enough? You might want to put some buffer, let's say to 5000. Yeah, just to be safe, I will just bump it to 5000. Okay, and I will run this. Run again. Okay, right now what is happening is now it's executing and it has finished. And we'll take a look at the way there is no warning. Here we go. There is no warning in this section. It's fine. And if you take a look at the last part of the output, it looks like it's finished itself. So with this setting, like 5000-ish context length of Ollama, you have room for the model to answer. Okay, so how does it compare with GPT-4o Mini? So I took a liberty to put in code that will create a model that will communicate with OpenAI server, and we will use GPT-4o Mini. I want to use 4o Mini because kind of like, I'm not going to use 4o because we are using Llama 3.23 billion parameter model. So it's smaller model. So I want to have downsize it to the smallest I can find. Right now it's like a 4o Mini. So I will just use that. I give it the same full prompt and I'll get the response back. Here we go. And this is the response from OpenAI GPT-4o Mini. It's a little bit longer. Visually, it's not like really rigor. So in this chunk of code, I just ran that chunk of code to actually see how these guys are compared. So the GPT-4o Mini, the output seems about twice longer compared to what Ollama has produced. And this can be because of my prompt, right? Notice that this AI for Mini can be smarter and it might have an inherent system prompt that asks it to do detailed summary. And it's a bigger model and it knows a lot more. Look at that. It has corrected Kapathy, the name. Look at this guy. This guy got the name spelling wrong because it doesn't really know much, right? This guy knows a lot, so it's supposed to be much better. Okay, the longer, the better is not true. Personally, I try to maximize the use of the context length, but then the result can, not suboptimal, can be not entirely related to the context length. For example, in this case, in this situation, I context length to like what, 10 or 100,000, so as close to the of Llama 3.2. And also I put the number of predict to -2. -2 means fill in the context length. And the result is not much different. It looks like it's stuck. It doesn't get much better than this because of the model's knowledge or something like that. Even worse, it took me 10 minutes to actually get this output. So all in all, well, by the way, 10 minutes on the M4 Pro MacBook. All in all, This parameter is open for optimizing. Again, the parameter, I mean the number of context length, is open for optimizing. If you want to implement it in your own application, the longer doesn't mean it's always better.